100 million particles that will be produced in order for this coloration to develop. So I can easily relate the uranium decay chain with this sort of schematic that you're seeing right here. And here's another uranium halo and another piece of mica. Again, now this was from the Black Hills. Earlier we were looking at something that came from a rock in Canada. And we can go to the other side of our world and go over to Germany, and there we can pick up minerals, pieces of mineral called fluorite from Bavaria, and we can section those minerals and look at them again, and there we see halos in a mineral called fluorite. And now we're going to see a little bit of the beauty that you see under the microscope as you study the phenomenon. We'll go rapidly through this series of slides. These are all uranium halos. They're of a different coloration. Some of them, like the one you're seeing right here, has an inner bleached area, and the reason is because it's what we call overexposed. Now over to the right there you can see a halo with two rings. Actually there's a third ring which you can hardly see. We're going to be talking about that in just a little bit more in a few minutes. But there are many different kinds of these unusual shapes and sizes under them you can see under the microscope. Many of them can be related, in fact most of them can be related in this particular instance, to what is happening just to uranium, something very, very common. Here's another overexposed uranium halo again in this fluorite. There's another overexposed uranium halo. There's another overexposed uranium halo. And now we go to a different part of the world. And I'm just showing you this to help you see a little variety of things that we worked with over the years. My invitation to come, as I'll be telling you a little while later, to come here to Tennessee did not result because of the work I'm doing relative to creation, but to something else. In this particular sample, in this particular halo, in this case, the inclusion or the center is quite large compared to the actual coloration itself. You can see the resemblance, of course, to the football field. That's an inclusion or a radio center there. And the yellowish coloration around that was produced by radioactivity in that yellow center. This particular sample and this one came from Madagascar. In fact, this particular halo right here that you're seeing is larger than anything that we can associate with any known type of radioactivity. And there's a real story behind all of that that is told in the pages of my book. I don't have time tonight, but just barely skim the surface of this one. So we'll go to the next one. Again, an unusual type of radioactive halo, which is thus far, I'll simply say I'm still working on the research on this one. These are the so-called dwarf halos that are found in the micas, the biatites, from Ytterby in Sweden. And again, their origin is presently unknown. But now we turn to something that we can identify, the single disc-like halo you're seeing here. And in the next slide, something a little bit simpler. You can see the two discs are the same here and in the last slide. And here's one of these same circular disc-like halos here in the fluorite. Now the size is a little bit different because what I've done, of course, is to take the photographs at different times under different magnifications. But the basic circular outline you see here, we're going to find out what it's due to in just a minute. Well, it turns out that the radius of this halo can be associated with an isotope of the element polonium. Now, the interesting thing here is the polonium that we're talking about here has a half-life that is relatively short compared to the supposed history of the Earth. The 138 days is what we have listed there. The next slide. And one of the most amazing types of the radioactive halos I've ever found, if you can believe it, this is a type of the polonium-210 halos in which you have an innumerable number of them all side by side. In other words, it's composed of maybe 50 or 100 or 200 of the polonium halos side by side in the pattern of a pair of spectacles. And so this was perhaps one of the most unusual ones I'd ever found, and I took pains to analyze it very carefully with some of the people I was working with at that particular time. And what we found, and I won't go into all the details tonight, but it's a part of the report which is reprinted in the book. What I found is simply that the little tiny centers there of this so-called spectacle halo all result from the decay of this polonium-210. In other words, we have a halo that is geometrically unusual and also unusual from the standpoint of the radioactivity. Well, this one has the two rings instead of just the one ring. We'll find out about this one in a moment. Here we have a number of these two-ring type halos. The next slide. And here we find that we can associate this two-ring halo with another isotope of the element polonium. Either it's 164 microseconds for the isotope itself, or in this case, there could be what we call a beta precursor with a half-life of around 27 minutes. Then we have some three-ring halos. We have the one ring, the single disc, the two-ring, and now the three rings, and this is in the fluorite, of course. Here another three-ring halo in the fluorite, and another set of three-ring halos, and this is now in a biotite or a mica. And we can associate this halo with the decay of polonium-218, and the half-life there is 3 minutes. Well, as I was doing this research over a period of time, and specifically, at least in the earlier stages, focusing on these uranium halos, I kept seeing these polonium halos. And I began to wonder how they formed. Well, the idea that was in the literature at that time, the reports, the scientific reports, was that these polonium halos had formed as a result of radioactivity that came from uranium. In other words, the polonium supposedly was simply somehow a decay product of the uranium series. And I accepted that idea for a considerable period of time. But as I kept on doing my research and my experiments, it became more and more evident that it was more and more difficult to associate a secondary origin. In other words, the idea was that radioactivity from a source of uranium had somehow separated from uranium and had traveled across the rocks, through the rocks, and had isolated itself in the tiny centers. But the problem, of course, was, number one, I didn't see any trace of the radioactivity going from one place to the other. I didn't see any of the uranium nearby that was supposed to be there. And then as I began to do the experiments, there are a whole number of different experimental techniques that could be used to show that there was no uranium nearby. And I began to puzzle more and more over how these particular types of halos had formed. Well, in continuing to do this and looking at these halos, I began to think more about the way in which I had been taught the history of the Earth, the origin of the Earth. The Earth, remember, coming from a long cosmic development. The Big Bang, 17 billion years ago, then the stars. But wait a minute, we can't have the Earth coming directly from the Big Bang because in the Big Bang itself, supposedly only hydrogen and helium are formed. So we can't get the Earth and the matter of the Earth today just from the Big Bang itself. We have to go through something else. And the something else is supposedly that stars, first-generation stars, form with hydrogen and helium. They burned and burned and burned. In the process of burning, nucleosynthesis took place. That is, heavier and heavier elements were accumulated, and then at last the star exploded. And as the star exploded, of course, the matter from the exploding star began to expand and expand and expand. And, of course, in the telescope today, we can still see the results of some of the supernovae that occurred almost 1,000 years ago, recorded, by the way, by the Chinese. Well, in any event, the Earth, then, has to be the product, in the conventional evolutionary viewpoint, has to be the product of a long series of stellar explosions. First-generation stars being formed, these stars burning, the stars exploding. And then you've got to go and reaccumulate the matter from these exploding stars and bring it together again somehow to form what initially in science today is known as the proto-sun. And the proto-sun supposedly had swirls around it, and those swirls eventually supposedly developed into the planets, one of which, of course, is supposedly our Earth. You see, once you get to the Earth, and we'll go on to the next slide now. Once you get to the Earth, then you have to have the Earth beginning to cool. And the kinds of rocks that begin to cool first are the rocks that I've been telling you about tonight, which contain these halos, these granites. Or in some cases, they are crystalline rocks associated with the granites, or the crystalline rocks underneath the granites. There's a whole complex of crystalline rocks in the lower parts of the Earth supporting the continents. And it's these crystalline rocks that supposedly began to form first as the Earth began to cool. So this rock here is one of those rocks that cooled supposedly over a long period of time as the Earth was evolving. Well, that's exactly what I had been taught, and that's exactly what I believed as I was contemplating the origin of these polonium halos. Well, if we go on now just a little bit further, here I've tried to outline the evolutionary model. The Big Bang, the stars form, supernova. Actually, you've got to have many, many supernovae and you've got to reaccumulate the end result of all that, the heavier elements, and then the solar nebula must form, the proto-Earth must develop, and the Earth begins to cool, and the Precambrian granites, the rocks that I've been telling you about, begin to form as a result of that. And specifically, if we look at our next line, we can see that the Earth forms, and then there's a long period of 4.5 billion years for it to cool down to where we are today. But, you see, if indeed the Earth was cooling down over a long period of time, I began to think, if these polonium halos were not derived from uranium, and they were formed from radioactivity that existed for just a short period of time, then we've got some